an equilateral triangle, which again it is a isosceles as well. So we're going to use that same idea. And so if I were to try to find the area of an equilateral triangle with a given perimeter. So if I sketch what I have, if my perimeter is 126 and a triangle has 3 sides of the same length, so 3s, I can solve for s by dividing by 3. So the length of each side is 3 goes into 12. 4 times 3 goes into 6 twice. So 42 is the length of each side of my triangle. If I want to find the area, I'm going to use the 1/2 base times height calculation. I know my base. Once again, it's not a bad idea to write out your base before you start working through, so it doesn't get, you don't mistakenly use the base of the right triangle once you create it. But because this is isosceles, when I draw in my altitude, it is going to cut this into 2 equal parts. And what else is unique about an equilateral triangle when you draw the altitude is the triangles that are created are 30, 60, 90 triangles. So this fits the pattern of x, 2x, x root 3. So if my hypotenuse is 42, that means the side opposite 30 degrees is going to be half of that, or 21, which means my whole altitude will be 21 root 3. And so I can plug that in. That's the height of my triangle. And so now it's just a matter of 42 divided by 2 is 21. And if I calculate this, you might be asked to write this in one of 2 ways. It might be asked to write it as an exact answer. If that's the case, 21 times 21 root 3 is just 441 root 3. The units are kilometers, area is 2-dimensional. So this would be your exact answer. And if you were asked to enter it rounding to a nearest certain decimal, you could find the approximate value as well, which would be 763.83 approximately. Still square units. And so that would be the other possible way that you might be asked to enter that.